Welcome back. Tonight's notes are on properties of quadrilaterals again, but I forgot to put in that this is Unit 7. So on the same page that you have Unit 6, let's just put Unit 7 because Unit 6 was so small that we can add in Unit 7 as well on into the same section as Unit 6. So Unit 7 is proof and conditional probability. So I'm going to write proof so put that just on the same page as Unit 6. That way our notes stay organized. Okay, so now let's flip over. So we did properties of quadrilaterals last time. This is going to be page 47. And this is going to be properties of quadrilaterals continued. Okay, so continued. Tonight we're going to put 2 more quadrilaterals into our notebook. The first one we're going to put is trapezoid. So trapezoid, we're actually going to talk about 3 different types of trapezoids. So we're going to draw 3 different types. So the first one will look like that. And this is just a trapezoid, a regular trapezoid. Or, excuse me, not a regular, just a trapezoid. Nothing special. The only property this has is it has exactly 1 set of parallel sides. Okay? So when you have a trapezoid, you're always going to have exactly 1 pair of parallel sides. Another type of trapezoid we could have this is an isosceles trapezoid. Which it still has exactly 1 set of parallel sides, but the other property that it has is 1 set of congruent sides. And then the last type of trapezoid we're going to talk about will look like that. And this is a right trapezoid. And a right trapezoid still has that exactly 1 set of parallel sides, but now it has 2 right angles. Okay, so as you can see, each trapezoid we drew still had exactly 1 set of parallel sides. That's what makes it a trapezoid. These 2 just have other special properties that go along with it. Okay, so that's trapezoid. Now moving on to rhombus. So rhombus. A rhombus looks like this. So that's a rhombus. The first property is that opposite sides are parallel. So we have opposite sides parallel. Just like a parallelogram. Opposite sides are parallel. But what makes this special and not a parallelogram is that all sides are congruent. So that's what makes it different from a parallelogram, where opposite sides are congruent. In the rhombus, all sides are congruent. Okay, the next one, if we draw diagonals, the diagonals bisect each other. So what that means is this is going to be congruent to this. That's going to be congruent to that, because they bisect each other. Another one is that the diagonals are perpendicular. So they make 90 degrees here. Okay, that's an important one to note. We do use that one quite often. And then the last property is diagonals bisect the angles. So what that means is when you take this diagonal, it bisects this angle, and those are the same, and then it bisects this angle, and those are the same. Okay, so I know we have a lot of markings there. Hopefully you can see what's going on. Now, when would we use these properties? Let's do a quick example. So you can tell that it's a rhombus because opposite sides are parallel. All sides are congruent. And it's asking you to solve for x. And it's that angle right there. It's the angle that is made by the diagonals. That's what it wants you to find. Now to do that, and looking at our properties, you know that that's 90 degrees. So you would just say 90 equals 3x plus 2. And our justification would be that the diagonals diagonals are perpendicular. And that's how we know that we can set that equal to 90. Okay? All right, thanks for watching.